My desk looks okay. I'm not in desperate need of an upgrade, but making things a little bit nicer is what tinkering is all about. In this short series, I'm going to go over a couple of little upgrades to my desk setup, both hardware and software. Plus, everyone loves a good desk upgrade. This video is going to focus on how to build this custom-made Macropad. In case you are unaware, a Macropad is a device used to send commands to your computer to perform either predefined or user-customized actions. The most popular commercial option is the Elgato Stream Deck. However, a simple Macropad could be made for as little as $10. There are perhaps hundreds of Macropad builds out there, ranging from standalone keypads with QMK firmware to custom wireless builds. And so many dials. For my build, I wanted to include an eink screen and several mechanical keyboard switches. I think eink looks very nice and allows me to have an always visible clock, something I could achieve in many other ways, but this is the way I wanted to try. Adafruit sells many such screens and microcontrollers that include connectors to directly attach them, so let's start with that. I opted for the 4.2-inch black and white model, together with the Adafruit RP2040 Feather Think-Ink board. As promised, the screen can plug right into the board and we can dump the sample code right onto it. The simple way of interfacing with these boards, in my opinion, is CircuitPython, a lightweight spin of Python meant for microcontrollers. Adafruit heavily supports this project too, so it's a natural choice for their boards. All we do is add the sample code, reboot the board, and voila, we have an image. E-ink screens are also really cool because they don't require power to maintain their state. Now, I knew that the e-ink screens could do this, but it is still a little bit trippy to see this just totally disconnected and the image is still staying on there. There is a downside, however. For this screen at least, the refresh rate is once every 3 minutes. Let me repeat that. Once every 3 minutes, not 3 times per minute. Yikes. So already this has me worried about the clock functionality. Traditionally, a clock updates once every minute. Let's carry on though. I verified that every pin I intended to use correctly registers inputs, as I've been burned on that before. I also verified I could connect 12 buttons at once, and that worked. Can you tell I'm really trying to not run into anything stupid before I order the PCB? I also added a simple output for a reading light in case you can't see the screen in the dark. The Featherboard has a NeoPixel on board, which can be used for other sorts of notifications. The next thing I wanted to test was interfacing back to the computer. That is the whole point of this thing after all. A Macropad can achieve this in a few ways. It might have all the commands baked into it. That is, if you press a button, it sends an "Open an app" command directly from the board. The other way this interface can occur is to have a companion app on the PC that receives the Macropad inputs and triggers the command. The advantage of including the command right on the device is that it becomes independent and can run on any computer that supports the same inputs. Additionally, if the board is Wi-Fi equipped, you could have it send something like an IoT command to control devices that are not the computer. However, anytime you want to make a change, you would have to modify it on device or reflash it, which may or may not be challenging. Conversely, by implementing a companion app, you can configure the Macropad on the computer and even have different functions depending on the context. But this also means if you want to use the Macropad on another device, you need the app as well, which is a little more clunky. On the other hand, you could have a different app on each device you want to use, so that may also be a benefit. My previous Macropad used the app-based method, and that worked pretty well. It was based around the Teensy 4.0, which sent key codes that I could normally never hit, like Control F13, which were picked up by a combination of Auto Hotkey and Event Ghost. Without giving away too much for the next video, I want to build a solution that is a little bit more multi-platform. Not to mention a lot of anti-cheat programs flag both AutoHotkey and Event Ghost as cheat tools. What I built then was a basic app in Python which receives commands from the pad and performs the desired action. This app could also send information back to the pad, such as notifications from Home Assistant. This is achieved with a simple serial connection to send data. With this, I can read the serial input and update the screen as appropriate. With all the testing done, it's on to hardware. Because the screen is a 4:3 aspect ratio, that gives a lot of options for interesting layouts. I thought it might be cool to put the screen on its side with the buttons arranged next to it, also in a 4:3 pattern. These 12 primary buttons are cherry-style linear mechanical keyboard switches. I'm also including 4 small tactile buttons for more menu type of functions, such as cycling through the displayed image, changing the button mode, etc. For mounting it, I wanted to put it right under my computer monitor because I think it will look cool and free up a little bit of desk space. So I designed a simple 3D printed arm that will stretch from the monitor stand to underneath the monitor. If you decide to make one of these for yourself, you might need to lengthen or shorten the middle section so it fits appropriately to your screen. The PCB is a simple design that connects all the buttons to the appropriate pins, along with some mounting holes for the arm. While I was in the middle of designing the PCB though, I realized it would be kind of cool to have a desktop version of it, so I designed some sloped feet for it to mount as an option. I decided on naming it the Dodecadeck in reference to the 12 primary buttons. With the parts arrived, it's just a short soldering session before it's all put together. The screen attaches with double-sided tape and a plastic frame completes the look of it. A few screws in and it's done. For the time being, the only thing the NeoPixel does is shine yellow whenever the screen is in a waiting to refresh state. Besides that, you can cycle between images using one of the tactile buttons, temporarily enable the reading light, and of course you have the 12 primary keys which can be defined for whatever you want to use them. And the clock? Well, it turns out it's worse than just being unable to update every minute. This board doesn't have a real-time clock on board, so unless I pass it some value from the computer, the board always counts up from January 1st, 2000. To solve that then, I have the app send a updated timestamp every 5 minutes or so, and so the clock is only giving you the approximate time. Besides that, you can add as many images as you want, and in the future, I might introduce some different operating modes to allow for even more key options. Source files will be on GitHub, and I hope you enjoyed this take on the well-explored Macropad genre. As I mentioned before, this is only part 1 in the desk revamp project. Part 2 should follow shortly after, where we finally hop the fence and start running Linux full-time. So, funny story. As soon as I stopped rolling, I was trying to diagnose an issue where it was kind of randomly connecting and sending every single key press all at once. And I was trying to take the screen off, and that dual-sided tape does not mess around. So 2 things on that. 1, maybe don't use so much DST as I did. It wasn't even that much, but just enough. And 2, it wasn't related to the screen at all. I think it's some sort of interference issue with the USB cable. So now you know. I'll make the mistakes so that you don't have to. Anyway, goodbye.